Hello students, this is Karthik, your maths tutor, heartily welcoming you all to Vista's Learning. What is Vista's Learning? Vista's Learning is an online education platform where we strive to deliver quality education for all. So we'll be continuing from the previous session wherever we had stopped. In the previous session, we had just an introduction to the second chapter of class 11th mathematics. So in the previous class, we studied Cartesian product. Okay, we know we have already studied what is sets in the first chapter. The second chapter we had studied what is Cartesian product. We'll be continuing from that. Okay, we'll be going to the next topic. All right. So in the previous class, students, we saw what is Cartesian product. The definition of the Cartesian product. Given two non-empty sets P and Q, the Cartesian product P cross Q is the final set of all the ordered pairs of elements from P and Q. Okay, so for example, we have taken one example. We'll take another one here. So let us take. Okay, so let us take P is equal to AB, A comma B, and Q is equal to 1 comma 2. So now P cross Q can be written as set of ordered pairs. So which means A1, A2, B1, B2. Okay, that is a Cartesian product. So A comma 1, A comma 2, B comma 1, and B comma 2. Okay, so this is the Cartesian product. So non-empty set P, it is having two elements. Non-empty set Q also, it is having two elements. So set of ordered pairs A1, A2, B1, B2. So in the set builder form, how is Cartesian product defined? So that is nothing but P cross Q is equal to PQ. So PQ means what I said. So these P's are the elements of set P and Q are the elements of set Q. Such that P belongs to P, correct? So A, B and B are belonging to P. So these are P elements. Small a and small b are the P elements where P are belonging to set P and Q are belonging to set Q. So 1 and 2. So these are Q elements denoted by Q elements, small q. So they are belonging to set 2. So this is called as what? A Cartesian product. So moving on to the next one, after Cartesian product, the next topic which we have is relations. So what is the meaning of relations, students? So basically relations means what? So relationships are present. So for example, there is a relationship between you and your mother, you and your father, something like that, correct? So we'll be seeing what are relations. So this is what is the definition of relation. So we'll see the definition first, okay, then I'll be explaining you this. What is the meaning of relation? So just read the definition, students. Okay, relation are from a non-empty set A to a non-empty set B. So non-empty set A and non-empty set B. So there are two non-empty sets A and B. So let us take, okay, A equals alpha, beta, gamma. All right, and let us take B equals 7 and 9. So now we have taken A and B, two non-empty sets. All right, or else we'll take numbers only. It will be easier for us. Okay, just a second. So here we will take 3 to 4 numbers each. All right. So let us take A is equal to 1, 2, 3, 4, and B will take it as 5, 6, 7, 8. Okay. A relation R from a non-empty set A, it's already defined, and a non-empty set B, that is also defined, is subset of the, so students see this. What is relation? Relation is a subset of the Cartesian product A cross B, correct? So what is A cross B, students? A we have, B we have. What is relation? Relation is a subset of the Cartesian product. So we'll find out what is the Cartesian product first. So A cross B. So this will be equal to, so how many elements will be there? So 4 and 4. So 16 relations will be there here. So what are those 16 relations? 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8, 2 comma 5, 2 comma 6, 2 comma 7, 2 comma 8, 3 comma 5, 3 comma 6, 3 comma 7, 3 comma 8, 4 comma 5, 4 comma 6, 4 comma 7, and 4 comma 8. So you have to put the brackets like this for each and every relation. Okay. So now the subset is derived by describing the relationship between the first element and the second element of the ordered pairs in A cross B. So these are the ordered pairs, students, whatever you're seeing inside this. Okay, these are the ordered pairs. Now, how is relation defined? Okay, relation is nothing but the subset derived by describing a relation. So box this. Okay, put a box for this. Describing a relation. Now we will define one relation. So we will define the relation in such a way that R is equal to A comma B. So what is A, students? Small a is nothing but the elements which are belonging to the set capital A, and small b are the elements which are belonging to the set capital B. So A comma B, so how is the relation, students? The relation is in the form of A comma B such that, okay, such that A and B both are even. So see this, so this is a relation what I am defining here. So you can tell both are odd or any other things, okay, you can also define here. So now relation is equal to A comma B such that A and B both are even means what? So we can write R is equal to, what can we write, students? A and B both are even. So this line is gone because 1 is an odd number. A and B both are even, 2, 5 is not even, 2, 6 is even. So let us write 2, 6. Next we have 2, 8. So this line is gone again because A is odd, 3. Next we'll be having 4, 6 and we'll be having 4, 8. So this is our relation. So whatever we have derived here, okay, this is called as a relation. So basically what is relation, students? Again, see the definition. A relation R from a non-empty set A to a non-empty set B is the subset of the Cartesian product A cross B. So see this relation whatever we have got here, this is a subset of this Cartesian product A cross B. Okay. The subset is derived by describing a relation. How did we describe the relation here? A and B both are even. So R is equal to A comma B such that A and B both are even. That is how we are describing the relationship, okay, between the first element and the second element of the ordered pairs in A cross B. The second element is called as the image of the first element. So now the second element is nothing but what, students? Okay, this side we'll see. So see this, 6 is the image of 2. 8 is the image of 2. 6 is the image of 4. 8 is the image of 4. So the second elements are called as what? The second element are called as images. What are the first element called as, students? The first element are called as pre-images. Okay, the first element are called as pre-images. So all these first elements are pre-images. So 2 is the pre-image of 6, 2 is the pre-image of 8, 4 is the pre-image of 6, 4 is the pre-image of 8, like that. Okay, so this is called as relation. Very simple. What is relation? Relation is nothing but a subset of the Cartesian product. Okay, and they are also defined as ordered pairs. So some more definitions related to relation, students. So one small example I have taken here. So this is that example. With this example, we have also defined what is a relation, okay, describing the relation, writing the relation, and we have also seen that whatever relation we got is the subset of the Cartesian product. Okay, moving on to the next one. So the set of first elements of the ordered pairs in the relation R. So in the relation R, in a relation R. So what is the relation we got previously? R equals 2, 6, 2, 8, 4, 6 and 4, 8. So this is the relation what we got previously in the previous slide. Okay, the set of first elements of the ordered pairs in a relation R from set A to set B is called as the domain of the relation. The domain of the relation. So what is the meaning of domain here, students? Okay, so domain is nothing but X, or it is nothing but called as pre-image, or it is also called as input. Okay, this is called as domain. Okay, X, set of X values. So A comma B, right? The relationship is described as A comma B. So standard form, students, X comma Y will be describing the relation. So where X is what? So that is what I have written here. X is nothing but the domain. So what is the domain here? 2, 2, 4, 4. So 2 comma 4 is the domain. Understood? So this is about the domain. See the next one. The set of all the second elements. So this is first elements, right? First elements are called as what? Domain. The set of all the second elements in a relation R from set A to set B is called the range of the relation. Okay, now see this. We got another term called as range. Here we got a term called as domain. Okay, range of the relation R. The whole set B is called as the codomain. So see this. This is called as codomain of the relation R. So three terms, students. One is domain, the second one is range, and the third one is codomain of the relation R. So there is one note here. Note that range is a proper set of codomain. Okay, so we got three words here: domain, range, and codomain. So what is domain, students? That is nothing but called as pre-images or the values of X, or that is nothing but input. Okay, and what is range? So here what is range, students? The set of all the second elements, 6, 7, 6, 8 it is. Okay, 6, 8, 6, 8. So the range is nothing but 6 and 8. So this is the range. Okay, this is the domain. 2, 4 is the domain. And what is codomain? Codomain, you see here, the whole set B is called as the codomain. The whole set B. So what was B, students? B is equal to 5, 6, 7 and 8. So this is called as codomain. This is called as domain. This is called as range. So they are telling that range is a proper set of codomain. What is the meaning of proper set? So for example, see what is range here, students? 6, 8. Okay, set 6, 8. What is codomain? 5, 6, 7, 8. 5, 6, 7, 8. So this is a proper set. Means whatever elements are present here, okay, that are present here as well, 6 and 8. But whatever elements are present in this set are not present in this set. So then we call it as what? Range is a proper set of codomain. Understood? So this is about domain, codomain, range. Previously we saw relation. Previous to that we saw what is Cartesian products. Alright. Moving on to the next one. So we have studied all these things. Okay, we'll do one very small example based upon this. So this will be relations. Okay. So we'll see the example, students. So example. So this is the given example. So from NCERT only. So if A is equal to 1, 2, 3, 4, 5, 6, define a relation R from A to A. So see, they have given only A and they are defining to asking to define a relation from A to A. So that is nothing but what, students? A cross A. By R, so see, this is the relation now. How are they describing the relation? X comma y such that y is equal to x plus 1. A to A they are telling to define, right? So let us take A here. Okay, let us write 1, 2, 3, 4, 5 and 6. So this is A. A to A again. So here also we'll write A. That is 1, 2, 3, 4, 5 and 6. Understood? So this is the relation, or this is the Cartesian product, whatever we will be taking, A cross A, from A to A. So R is equal to xy such that y is equal to x plus 1. So what are these values, students? We'll change the color here. Okay. So what are these values? These values are x. And what are these values? These values are y. Okay. So such that y is equal to x plus 1. So if x is equal to 1, what is y? 2. If x is equal to 2, what is y? 3. X is 3. If x is equal to 3, then 4. X is equal to 4, then 5. If x is equal to 5, then it is 6. If x is equal to 6, then it is 7. But 7 is not given here. So we are leaving that. Okay. And 1. So when can y be equal to 1? When x is equal to 0. So again 0 is not given in the set, right? See, whatever is given in the set only we are writing it here. So this is A. This is again A. So why are we multiplying A and A again? Let A is equal to 1, 2, 3, 4, 5, 6. Define a relation R from A to A. So from A to A. So we are defining a relation such that R is equal to xy, y is equal to x plus 1. Okay. So they have given two more sub questions there. So what are those? Depict this relation using an arrow diagram. So student, this is an arrow diagram. So see this. So from A to A, depict the relationship using an arrow diagram. This is that arrow diagram. Okay. And write down the domain, codomain and range of the relation. So for now let us write down the relation. What is the relation, students? Relation R will be equal to, okay. So 1 comma 2, 2 comma 3, 3 comma 4, 4 comma 5, 5 comma 6. Close the bracket. So after 5, that's it. Finished, right? There is nothing more. Now we have to write what, students? We'll write domain, codomain and range. So what is domain? Set of all the first values. So what are the first values here? See the first value, students. 1, 2, 3, 4, 5. These are all the set of first values, right, in the relation. So domain is nothing but, open the flower bracket, 1, 2, 3, 4 and 5. So this is domain. Okay, moving on to the next one. Codomain. So what is codomain? Set of B values. So B values, so we do not have B, we have taken A only. So this set of values will be called as codomain. So what is codomain there? 1, 2, 3, 4, 5 and 6. So this is codomain. And we have also write down the range. So what is range, students? Set of second values. So set of second values means, see the second values here, 2, 3, 4, 5 and 6. So these are set of second values in the relations or in the ordered pairs. So that is nothing but the range. So here we can write range equals 2, 3, 4, 5 and 6. So now just check whether R is a proper set of codomain. Yes or no, students? So what is the meaning of proper set? All these elements are present here, but there is at least one element in codomain which is not present in R. So then we can call range is a proper set of codomain. So this is one example. So this is domain, codomain and range. This is one small example which we have done. Okay. So arrow diagram, I'll draw it properly once. Okay, in the next slide. So the arrow diagram is something like this, students. Okay, so just make a note. So this is from A, okay, to A. So here we'll write 1, 2, 3, 4, 5, 6, 2, 3, 4, 5 and 6. Okay. So the arrow diagrams represented like this. So if x is equal to 1, y is equal to 2, put an arrow mark. 2 to 3, if x is equal to 2, y is equal to 3. X is equal to 3, y is equal to 4. X is equal to 4, y is equal to 5. X is equal to 5, y is equal to 6. Where is that given, students? So see here, y is equal to x plus 1. So here we'll write again. So here all these are values of y. So y is equal to x plus 1. If x is equal to 1, then y will be equal to, so this is an arrow diagram. Okay. So that is all in this session, students. So we have finished the next topic after the Cartesian products, which is called as the relations. In the next session, we'll be seeing what are functions and few examples on them. Okay. So please do like the video, share and subscribe. Thank you, students.